Hello everyone. This video is about memory management, and from this we are going to discuss about the page replacement algorithm. So as we have seen, actually there are three algorithms for page replacement: FCFS, LRU and Optimal. Out of these three, in the last two videos we have seen FCFS and LRU algorithm, and today we are going to discuss about the Optimal algorithm. So if you have not checked the videos for the FCFS and LRU, please go through the two videos. Link for both of them is given in the description box below. So let's start with the optimal algorithm today. So here also page reference string is given. Here we are considering one process, and that process requires 10 pages for the execution. As the pages are not continuously placed, so the page reference string is given here. As you can see, total number of pages are given as 10. Now the total pages cannot be present in the main memory, so that's why out of these few pages will be loaded. Now that few pages size will be decided by page frame size. So it is given as 3. So out of these pages, 3 pages will be loaded in this particular frame. And then once this frame is full, we will have to go for the replacement of the page. Now here the replacement will be decided by optimal algorithm. And what is that algorithm? That we are going to see with the help of example in the next slide. So here page reference string is given to us as we have seen in the previous slide. Total number of pages used in this particular process is total 10 pages. Now in the last two algorithms we have seen there was only one table, but in this case for this algorithm we are going to use two tables. Now this first table is going to be same, only there is a difference in the second table. So the second table is nothing but the forward page reference table. Now here we are going to find out the forward reference for the current page. That means whether this particular page, now here if we see page number 1 is there, and whether it has the forward reference. So in this case, yes, it is there, and it is after 1, 2, 3, 4, 5 pages. So for this current page 1, forward reference is 5. And after this also it is getting used after 4 pages. So page number 1 is getting used 3 times. At the starting, page number 1, after 5 and after 3. So in this case it will be coming as 5 here. So I hope the idea of forward reference is clear. Now we are going to see how the pages will be loaded in the memory. So CPU is going to request for the first page. So page number 1 is there. So page number 1 will be loaded from secondary storage into main memory. As it is a new page, there will be a page fault. Now as I told you, for this current page 1, forward reference is 5. So this table, in this case we are going to load the distance, forward distance, so that is going to be 5. Now CPU is requesting for this page number 2. So page number 1 will remain as it is and page number 2 will be loaded here. Now as it is again a new page, there will be a page fault. Now if you see whether there is a forward reference for this page number 2, so yes, it is there here. So it is after 1, 2 and then 3. So forward reference for this 2 is 3. So in this table here at the second location we are going to fill up as 3. Now what about this 5? Now 5 has passed one page, that's why 5 will become 4. After that it will become 3, 2 and likewise. So 5 has become 4 and distance for page number 2 is 3. Now CPU is requesting for page number 3. So page number 1 and 2 will remain as it is and page number 3 will be loaded here. Again, as it is a new page, there will be a page fault. Now distance for this 3. Now if you see the page reference string here, page number 3 is not getting used after this any time. So distance for this 3 will be infinite. And 4 will become 3 and 3 will become 2. That was the page reference for the page number 1 and page number 2. Now if you see, page frame is full now. Now CPU is requesting for page number 4. So we cannot directly load the page into the frame, so we will have to replace one of the page. Now as this is the optimal algorithm, so we will have to check this second table. Now we are going to see whether which page is getting used at largest distance. Now in this frame, if you see, this is 3, this is 2, and this is infinite. So out of these three values, infinite is the maximum value, and infinite reference is related to page number 3. So that's why page number 3 will be replaced by page number 4. So whichever will be the maximum distance, that will be selected, and then accordingly we are going for the page replacement. So here we have replaced the page 3 by 4. Now as page number 4 is again a new page, there will be page fault. Page number 1 and 2 will remain as it is, and page fault will occur. Now we will see the distances for page number 1, 2 and 4. Now if you see for 4, whether it has the forward page reference. So yes, here after 3 pages, 1, 2 and then 3. So for this 4, distance will be 3. Then this 3 will become 2 and this 2 will become 1. Now after this, CPU is asking for page number 2. Now if you see here 1, 2 and 4, page number 2 is already there. So no need to load it from the secondary storage into the main memory. As the page is already present, there is a page hit. So there is a page hit for this particular page. Page number 1 and 4 will remain as it is. Now if you see, there is no forward reference for page number 2 here. So that's why distance for this 2 will become infinite at this location. Then this distance 2 will become 1 and this distance 3 will become 2. Now next page is page number 1. Now page number 1 is already there in the memory. So no need to load it from the secondary storage. So 1 will be loaded here. Page number 2 and 4 will remain as it is. And there is a page hit. Now we will see whether the distance for this page number 1. Page number 1 is again getting used after 4 pages. That's why there is a forward reference for this as 4. So actually if you see here it is 1 and after 1 it should become 0, or it actually if there is no forward page reference, then it should become infinite. That means we are not going to use that particular page anymore. But here that is not the case. Page number 1 is getting used after 4 pages. So distance for that will be 4. And now you can see here it is the 4. This infinite symbol will continue as it is, because for this particular page number 2 there is no forward reference. Okay. So this will be infinite. And this 2 will become 1. Now next CPU is asking for page number 4. Page number 4 is again already present in the memory. So that's why there is a page hit. Page number 1 and 2 will remain as it is. And page hit is denoted by H. Now is there a forward reference for page number 4? So it is not there. So 4 is not getting used after this. So that is infinite. This 4 will become 3 and infinity will continue as it is here. Then CPU is asking for page number 5 now. Now page number 5 is not there in the memory. So we will have to load it from secondary storage into main memory. Now again we are going to refer this particular table where we are going to check the maximum distance. So here if we see 3, infinite and infinite, these are the 3 values. Out of this 2 infinite, which infinity symbol shall be replaced? So out of these 2 infinite symbols, which infinite symbol came first? So if you see, this came first, this infinity symbol. So this is related to page number 2. So that's why we will replace the page number 2 by 5. Page number 1 and page number 4 will remain as it is, and there will be page fault. As new page 5 we have loaded here. Now for this page number 5 there is no forward reference. so distance for this will become infinite here. Then this 3 will become 2 and this infinite will continue as it is. CPU is asking for page number 6 now. Page number 6 is not there in the memory. So again check for this particular table. Now again there are 3 values, 2, infinite and infinite. Now out of these 2 infinite, this infinity symbol came first. So this is related to page number 4. So 4 will be replaced by 6. And page number 1 and 5 will remain as it is. As it is a new page, there will be a page fault. Page number 6 is also not getting used after this. So distance for that or forward reference for that 6 will be infinite. This 2 will become 1 and this infinity will be infinity only. Last page, CPU is asking for page number 1. Now if you see, page number 1 is already there in the memory. So there is a page hit. Page number 5 and 6 will remain as it is and there is a page hit. Now at the last, this one is not getting used and process has completed by using all the pages. So this, for all the pages, there is no forward reference. So in the last column, we will get all the values as infinite. And likewise, the algorithm will execute. Now in this case also, if you see, there are 4 page hits and 6 page faults. From this page hits and page faults, we can find out the hit ratio as well as we can find out the fault ratio. Now number of pages, page hits and page faults we have seen in the last slide. So there were 4 and 6 respectively. From that we can find out the hit ratio and we can find out the fault ratio. So as we can see, hit ratio for this is 4 upon 10 into 100, that is 40%, and fault ratio is 6 divided by 10 into 100, that is equal to 60%. So as we have seen, for FCFS, LRU and optimal, these two parameters, that is hit ratio and fault ratio, was calculated, and now we can compare the 3 algorithms using this parameter. Now comparison of these 3 we are going to see in the next video. So thank you for watching, and for any queries please give the comments in the comment section.